Suppose a fixed volume container initially contains 2 moles of gas at 0.500 atmospheres. The gas decomposes and, hours later, the pressure at the same temperature is found to be 0.800 atmospheres. How many moles of gas are present in the final mixture? Since this problem involves gases, let's see how we can use the ideal gas equation, PV equals nRT, to solve this problem. We know that in this equation, R is a constant. The problem tells us that a reaction occurred in a fixed volume container and that the final mixture is at the same temperature as the original gas sample. Therefore, for this particular problem, the volume and the temperature are also constant. Since we're not given the values for volume and temperature, we need to find a way of solving the problem without having to use these values. Let's rearrange the ideal gas equation so that all the constants are on one side of the equation. If we do that, we get P over N is equal to RT over V. Note that the right-hand side, RT over V, is a constant, since R, T, and V are all constants. What this means is that even though the pressure P and the number of moles of gas do change in this problem, their ratio is constant. P over N is equal to a constant. When the ratio of two quantities is a constant, we say that they are directly proportional. This means that, in the case we have here, pressure is directly proportional to the number of moles of gas. The more moles of gas we have, the higher the pressure. In other words, the increase in pressure given in the problem to be from 0.500 atmosphere to 0.800 atmosphere is due to an increase in the number of moles of gas as a result of the reaction. We have enough information here to figure out the final moles of gas. If we refer to the initial pressure in moles as P1 and N1, and refer to the final pressure in moles as P2 and N2, then we know that for this particular problem, where V and T are constant, P1 over N1 must be equal to P2 over N2. We can rearrange this equation to solve for the final moles of gas. The final moles of gas, N2, is equal to the original moles N1, which is given in the problem as 2 moles, times the ratio of final pressure to the original pressure, P2 over P1. P2 is given as 0.800 atmospheres, and P1 is given as 0.500 atmospheres. Performing the indicated calculation gives us 3.20 moles as the value of N2. The total number of gas molecules in the final mixture is 3.20 moles.